Hello, everybody. Today is section 3.2, day 2. It's going to be the same title as last time, as yesterday, day 1, solving power and root equations. Continued. We're actually going to pick up right where we left off from yesterday. The warm-up will be, which I would like you to genuinely try on your own first, please. Please work on 2 times x plus 1 to the 4/3 minus 8 equals 24. Remember, your goal is to isolate the power term first before you take the inverse. So press pause and go ahead and try this, and then we'll come back and work on it together. Now that you have all tried it, let's see if we match answers. The first thing I'm going to do is add 8 to both sides. So I'm bringing down this piece equals 24 plus 8 is 32. I see that this is 2 times this piece, so I can divide both sides by 2. And I now have x, that's supposed to be x plus 1 all to the, I want to move that over. Side note, like a housekeeping thing, you know that we're going to end up raising this to something else, so it's not a bad idea to like move over a little bit. So even myself, I was coming super close to this line, and I don't want my fractions to get squished. So if you can kind of mentally move over a little bit so you have space left here, that would really be helpful for you. 32 divided by 2 is 16. Now, this power term or root term is as by itself as it can get, so now we're ready to use our inverse operations. The inverse, or the reciprocal of 4/3, would be 3/4. So I raised both sides to the 3/4. Notice how I was able to very neatly write 3/4 right there because I had space. 4/3 times 3/4 is 1. So this cancels out. That was the whole intention, is to cancel out the 4/3 by multiplying it by its reciprocal. So I'm left with x plus 1. Now starts our chart knowledge. So if you have not made flashcards, it is incredibly important that you do so. Because I know that you can write 16 as 4 squared, but if I notice, I'm talking about a 4th root. So if it's possible to write this as something to the 4th, that's very useful to me. How do you write 16 as something to the 4th power? 2 to the 4th. So I can rewrite 16 as 2 to the 4th, and this is raised still to the 3/4 power. X plus 1 will chill out for a sec over here because I can work on this. I'm going to put a little mental bubble. That becomes 2 to the 12/4. 12 divided by 4 is 3. So this is 2 to the 3rd. That becomes x plus 1 equals 8. Subtract 1. Subtract 1. X equals -7. Typo, sorry, not -7, 7. And we're done. X equals 7. For our board notes today, we will be just continuing the examples from yesterday. I had mentioned that in today's class. So you can actually just put 8. We left off at 7 in the notes. We're going to start with 8. If you want to give this title, you can put more solving examples. Number 8 says, the third root of x minus 4 equals 0. What are we going to do first? As always, I want to isolate the root term or radical term first. If there's something I can add or subtract, I will do that first. So I will add 4 to both sides. So I have the third root of x equals 4. To undo a third root, the inverse operation would be to raise both sides to the third power. In class today, we talked about how the third root of anything is the same as raising something to the 1/3. So to undo a 1/3, or to get this to be a 1, I'd have to be able to multiply it by 3. So mentally, when you see third root, you have to visualize that you have this fraction, 1/3, which is why raising both sides to the third power will work. So, coming back to our problem, the third root and the third power cancel, leaving just x. 4 to the third is 64, and I'm done. Because this is an odd power, I do not have to worry about a check. Number 9, 2x to the 3/2 equals 250. We want to isolate the term that has the rational exponent. To do that, this says 2 times, so to undo the multiplication, we will divide both sides by 2. 2's will cancel. I have x to the 3/2. Even that's a little close for me. I'm going to move it over a little bit. Give yourself space to write those fractions. 250 divided by 2 is 125. What are we going to do next? Well, this is as by itself as it gets. To isolate x further, the reciprocal of 3/2 is 2/3. So I will raise both sides to the 2/3. 3/2 times 2/3 cancels out because 3/2 times 2/3 equals 1. They're reciprocals. So I get x equals, question. 125 is on your chart. I'm talking about the third root. So can I rewrite 125 as something to the third power? The answer is yes. What to the third power equals 125? I hope everybody right now is saying 5. 5 to the third equals 125. And I still have 2/3 here. I have to be careful. Sometimes if I don't leave space, it looks like a 4. 2/3. Mental bubble. 3 times 2 is 6, so that's 5 to the 6/3. I'm totally cool if you right away see that this becomes 5 squared, because 6 divided by 3 is 2. So my answer, x equals 25. And we're done. This was an odd root. See, the 3 is odd, so there was no plus or minus. Number 10. Says -4 equals square root of 2x minus x. Now, this is a little different. We haven't really looked at one like this. I mean, trying to rewrite this as 2x to the 1/2 still doesn't really help me out because I have this minus x in the mix now. So our strategy will be isolate radical, so you can raise both sides to a power. So what does that mean for this example? Well, here's my radical. Let's move x. So I'm going to add x to both sides. This has become x minus 4 on the left, and now I have the square root of 2x all by itself here. I have isolated the radical. What's nice about that is the opposite of square rooting is squaring. If I raise this side to the second power, I raise this side to the second power. That is the only way that I can get rid of this square root. And if I raise this side to the second power, got to raise this side to the second power. We're ready to use our algebra skills to solve. So x minus 4 all squared becomes x squared minus 8x plus 16. I'm going to move that up a little bit. X squared minus 8x plus 16. I'll get the mental bubble going on over here. Remember that x minus 4 all squared means x minus 4 times x minus 4. So use your arrows, right? X times x, x squared, minus 4x, minus another 4x, plus 16. That's what we just did right there. The square root and the square cancel, leaving 2x. Let's get this set equal to 0, and hopefully we'll be able to factor. I'll subtract 2x from both sides. Ooh, sorry, didn't mean to cross that out. This crosses out. I get x squared minus 10x plus 16 equals 0. A is 1, which is super nice. I'm looking for two numbers that multiply to a positive 16 and add to negative 10. Go ahead and factor that, see what you get. This will factor to be, oh, I lost my spot. Hold on. X minus 8, x minus 2. Equals 0. And then to actually get our solutions, we set up these two little equations, right? So I get x equals 8 and x equals 2. This is the first time where we will be dealing with an extraneous solution. So way up here, as soon as I raise this to the second power, I want us to write check. Remember from yesterday's notes that as soon as you raise something to an even power, we will have to check. So let's see what happens. Checking x equals 8, that'll be negative 4 equals the square root of 2 times 8 minus 2. This is a check. So that becomes negative 4 equals the square root of 16 minus 2. Negative 4 equals 4 minus 2. Oh, I messed that up. Back up, back up, back up. Sorry, I just stepped away for a moment, so I'm trying to recenter myself on these notes. Okay, so it's negative 4 equals root of 2 times x minus x. So that'll be a minus 8. Apologies. Okay, problem solved. Negative 4 equals 4 minus 8, negative 4. Check. That worked out. How about checking x equals 2? So that will be negative 4 equals, I'm just going to keep it scrolled up for a second so I don't lose track of the original equation. 2 times x, which becomes 2 times 2 minus x, so minus 2. All right, so let's see what we get. Negative 4 equals the square root of 4 minus 2. Negative 4 equals 2 minus 2. We get negative 4 equals 0. That is false. Does not work. So we actually cross this one out and write extraneous solution. The only real answer to this one is x equals 8. So here's an example of, in the process of solving, because we ended up squaring as part of our work, x equals 2 is not an actual answer. It's extraneous. So we have to check. So from now on, if we ever raise something to 2, 4, 6, any even number, we're going to write check in a box. So that when we're done, we're like, oh, not done. We have to run a check. Number 11. 3 times x minus 1 to the 4/3 minus 6 equals 237. Go ahead and press pause. Work on this one on your own, and then come back and we'll compare our answers. I'm going to add 6 to both sides. I get 3 times x minus 1 to the 4/3 equals 237 plus 6, 243. We'll divide both sides by 3 to continue isolating this term. 243 divided by 3 is 81. We're now ready to raise both sides to the 3/4 power, because 4/3 times 3/4 will cancel, leaving x minus 1 equals. How can we rewrite 81? Now, some of you might be thinking, well, I'm going to draw an arrow to 4 and write plus or minus. But we're not going to do that because we can actually still work on 81. So we're not ready to say yet that this is an even root yet. I can rewrite 81 as 3 to the 4th. I chose to write this as 3 to the 4th and not 9 squared because I see I'm dealing with a 4th root. This is now x minus 1 equals, mental bubble off to the side. That becomes 3 to the 4 times 3 is 12/4. So 3 to the 3rd. This is now back in most simplified form. It's an odd power, so no need for plus or minus here. So x minus 1 equals 27. We'll add 1 to both sides. X equals 28. And we're done. Number 12. Square root of 3x plus 2 minus 2 root x equals 0. We're actually going to take some notes off to the side, so let me move this over. When solving equations,
attention please. Diamond Crystal McDowell. Diamond Crystal McDowell.
With 2 radicals. Simplify equations so that each side, simplify equation so that each side only has 1 radical. then raise both sides to an appropriate exponent. So when solving equations with two radicals, we're going to simplify the equation so that each side only has one radical. Like right now, there's 2 on one side. Once that happens, we can then raise both sides to an appropriate exponent. So let's see how this is going to work. I'm going to move this radical to the other side because I only want 1 on each side. So this becomes square root of 3x plus 2 is left on the left side. And on the right side, I have this 2 times the square root of x. Now I can raise both sides to an appropriate exponent. In this case, these are both square roots. So if I square both sides, I will be able to get rid of those radical symbols. Now notice, we've raised it to an even power. So I want you to draw an arrow here, and I want you to write check. Because when we're done, we're going to have to check our answers. So when I square this left side, that will result in 3x plus 2, because the square root sign and the square cancel. We send the power to both the 2 and the radical. So this will become 4x. Notice how nicely this has worked out to something that we can finish very quickly. I choose to keep x's positive, so I will subtract 3x. X equals 2. Notice your little note. We need to check this answer to make sure it's not extraneous. So check. Very carefully, plug it in. Don't make the mistake I made by accident before. 3 times 2 plus 2. Wherever I see x, I'm plugging in 2. All right, double check. X is 2 here, 2. Let's see what we get. So 3 times 2 is 6, plus 2 is 8, minus 2 root 2. I know that I can break up 8 to be the square root of 4 times the square root of 2, minus 2 root 2 is 0. Square root of 4 is 2. This just keeps coming down. 2 root 2 minus 2 root 2, that is 0. 0 equals 0, check. So now I know that this is not extraneous. It is a real solution to the equation. Can't say it enough. As soon as you raise something to an even power, 2, 4, 6, 8, write the word check. Put it in a box. So that way when you finish, you remember to go do a check. That wraps up 12. We have 3 more to go. 13. 13, the fourth root of 2x plus the fourth root of x plus 3 equals 0. I see that I have 2 radicals on one side. I can't do anything with that. I want to be strategic and get one of these radicals to be on the other side, so then I can raise both sides to a power. Does not matter which one you move. I choose to move this one. So I get the fourth root of x plus 3 equals negative fourth root of 2x. These are both fourth roots, so if I raise both sides to the fourth power, I will be able to get rid of the radical signs. 4 is an even power. I will need to check my answers. The radical sign cancels on the left, so I have x plus 3. Negative 1 to the fourth power is positive 1, so we don't have to write it. But be aware, if this was a 2, for example, you would actually need to do 2 to the fourth, and that number would go right here. So again, this represents negative 1. Negative 1 to the fourth power is 1, so I have nothing to write. The fourth root of x and the power of 4 cancel out, so I have 2x. To wrap this up, I will subtract x from both sides. And we get x equals 3. But we're not done. I see my little note over here I need to check. So check. Very carefully make sure that we substitute this in correctly. Substitute this in correctly. So that'll be the fourth root of 2 times 3 plus the fourth root of 3 plus 3 equals 0. Let's see what we get. Again, double check. Did you plug in x correctly? Fourth root of 2 times 3, that's good. Plus fourth root of 3 plus 3. Yep, we wrote it properly. And now let's do it. This becomes the fourth root of 6 plus the fourth root of 6 equals 0. That becomes 2. Fourth root of 6 equals 0. That is false. This is an extraneous solution. So we actually write no solution for this. The answer for 13 is no solution because the one that we did get was extraneous. Number 14, second to last example, 14. Square root of 2x to the fourth plus 5 equals square root x to the fourth plus 13. See if you can do this one by yourself. This is going to drive me crazy. I'm going to write it neater. Okay? So square root of 2x to the fourth plus 5 equals the square root of x to the fourth plus 13. It's nice because I already have one radical on each side. So make a decision on what you need to raise both sides to. Press pause when you're ready to compare solutions with me. We'll check. Okay, so I'm going to raise both sides to the second power. I can do that right away because I have a radical on each side. They're both square roots, so raising to the second power works. Right away, I see that I'm raising to an even power, so I'm going to write myself a note that I need to check my final answer once I get there. This becomes 2x to the fourth plus 5 equals x to the fourth plus 13. I will subtract x to the fourth. Keep doing that. Okay, this becomes x to the fourth plus 5 equals 13. Subtract 13 from both sides. Sorry guys, I'm tired. That doesn't make any sense. Let's move 5. X to the fourth equals 13 minus 5 is 8. I will raise both sides to the 1/4. 4 and 1/4 cancel.
Demetrius, to the front lobby.
I've got x
Demetrius,
equals,
front lobby.
I can rewrite 8 as 2 to the third. So let's do that. Which becomes x equals 2 to the 3/4. Now we're not done yet because we need to run the check. I'll put it over here. So into our original function, that would be the square root of 2 times 2 to the 3/4. I think I'm going to have to extend this bar over a little bit. 2 times 2 to the 3/4 raised to the 4th power plus 5 equals the square root of 2 to the 3/4 to the 4th plus 13. As crazy as this looks, it's going to work out nice because underneath the radical, 3/4 times 4, mentally, 4 times 3 is 12, divided by 4 is 3. So this becomes 2 times 2 to the 3rd plus 5 equals, same thing happens on this side, right? 3 times 4 is 12, divided by 4 is 3. So this becomes 2 to the 3rd plus 13. We know 2 to the 3rd is 8 times 2 is 16 plus 5 is 21. 2 to the 3rd is 8 plus 13 is 21. Square root of 21 equals square root of 21. Check. We have verified that this is a real solution. Last example, 15. Square root of 3x plus 1 equals square root of x minus 5. Go ahead and give this one a shot all by yourself, all the way through. When you're done, press play and we will compare answers. I have a square root situation, so I can raise both sides to the 2nd power. As soon as I do that, I'm going to write myself a note. Check. So when we're done, we're going to have to come back and check our answers. So 3x plus 1 equals x minus 5. I will subtract x. I get 2x plus 1 equals negative 5. Subtract 1 from both sides. 2x equals negative 6. Divide by 2, divide by 2. X equals negative 3. Look at my note. I told myself I have to check it, so let's check. So that'll be, wherever I see x, I'm going to plug in negative 3. So 3 times negative 3 plus 1 equals the square root of negative 3 minus 5. That gets me the square root. 3 times negative 3 is negative 9, plus 1 is negative 8, equals the square root of negative 8. Now, at first glance, you may say that these are equal, but notice we have negatives under the radicals. This means that we have an imaginary number under the radical. So even though this is technically a true statement, because these are imaginary, it's not a real solution. So I have to come over here. Don't scribble it out. Just gently cross it out so that way I can see what your answer was. But I want you to realize and show me that you realize this is not an actual solution. Put extraneous solution. And this was our only one, right? It's not like I had 2 and 1 came out true and then I just have to say not this one. This was our only one. So the answer here is no solution. And that's it for today's notes. So today in class, you are working on that day 1 and 2 homework worksheet. With this set of examples, you should be in good shape in tomorrow's class to continue working on those examples in class. If you would like to work on them after these notes, you're more than welcome. But technically, working on that worksheet is part of tomorrow's class. Any questions on these board notes, please take a picture of the part you have a question on, send it my way, and I will help you out. Have a great day, everybody. See you tomorrow. Bye.